Gazing beyond the horizon, from the dawn of human curiosity, we have always looked upward. The night sky, glittering with countless stars, has been a canvas for myths, gods, and imagination. For millennia, humans relied on their unaided eyes to glimpse the cosmos, weaving intricate stories about constellations, planets, and celestial phenomena. Yet, for all its beauty, the naked eye had limits. Distances too vast, stars too faint, and planets too small remained tantalizingly out of reach. Imagine standing on a quiet Dutch canal in 1608. The air smells faintly of wet wood and freshly cut reeds. Boats rock gently as merchants shout their wares. Somewhere, in a small workshop cluttered with spectacles and lens-making tools, a craftsman bends over a curious contraption. He squints through a pair of carefully polished lenses. Suddenly, distant church towers, barely discernible with the naked eye, appear close and crisp as though he could reach out and touch them. This man is Hans Lippershey, and he is about to change the way humanity sees the universe. This is where our story begins, with a simple combination of glass, craftsmanship, and curiosity. The first telescopes were not shiny, high-tech instruments like Hubble or Webb. They were humble, handmade tools, yet they opened the doors to a universe previously hidden, a universe that would soon challenge human understanding, philosophy, and religion. Hans Lippershey, the spectacle maker who stumbled upon genius. Hans Lippershey, 1570–1619, was born in Wesel in what is now Germany and moved to the Dutch Republic, a hub of trade, art, and innovation. As a spectacle maker in Middelburg, Lippershey worked with lenses daily, grinding, polishing, and fitting them into frames for reading or distance vision. It's important to note, spectacle making at the time was both an art and a science. Lenses had to be shaped precisely, imperfections minimized, and curvatures calculated by hand, often through trial and error. The story goes that Lippershey might have been inspired by a pair of lenses accidentally aligned in a certain way, magnifying a distant object. Whether it was a happy accident or deliberate experimentation, the result was revolutionary, a device that made faraway objects appear near. This simple idea, combining a convex objective lens with a concave eyepiece, formed the core of the first practical telescope. Lippershey's design was modest but effective. The device allowed for 3 to 9 times magnification, depending on the quality of the lenses and the distance between them. It was roughly a foot or 2 long, cylindrical, and handheld, more akin to a spyglass than the tall observatory telescopes we think of today. But it worked. And that's what mattered. The Dutch patent and the birth of a controversy. In 1608, Lippershey applied for a patent in the Dutch Republic. His intention was practical. A telescope could be used for military reconnaissance, spotting enemy ships before they arrived at the coast. Imagine Dutch sailors squinting at the horizon, watching fleets appear seemingly out of nowhere. The telescope promised a strategic advantage, a window into the unknown, even if just a few miles away. Interestingly, Lippershey's application was rejected, officially because other spectacle makers could replicate the device with relative ease. Some sources suggest that authorities were wary of granting exclusive rights for something that seemed simple but could have profound implications. Nonetheless, word of the invention spread like wildfire. Other Dutch lens makers, including Jacob Metis and Zacharias Janssen, claimed to have invented similar devices around the same time. The exact first inventor remains debated, but Lippershey's name endured, largely because of the visibility of his patent attempt. It's fascinating to consider the optics behind Lippershey's telescope. The convex objective lens gathered light and bent it to a focus, while the concave eyepiece allowed the observer to see the image upright and magnified. This design, later called the Galilean telescope, became the standard for early handheld instruments. Simple in concept, yet its consequences were enormous. Impact on navigation. Before the telescope, sailors relied on simple maps, compasses, and naked eye observations to navigate treacherous waters. Ships were vulnerable to storms, enemy fleets, and hidden reefs. The telescope revolutionized navigation by allowing lookouts to spot distant objects earlier, providing precious time for maneuvering. Military strategists quickly recognized its potential. High vantage points became observation posts, and coastal defenses were upgraded with telescopes to watch for approaching fleets. In a sense, the telescope's first true application was terrestrial. It served practical, immediate human needs before it became an instrument of science. Its invention demonstrates a recurring theme in technological history. Devices often emerge for one purpose and then find their greatest impact elsewhere. The leap toward astronomy. While Lippershey likely never aimed his telescope skyward, the implications for astronomy were obvious. Once news of the telescope reached scholars and natural philosophers, the question arose: if it can make distant terrestrial objects clearer, what can it reveal in the heavens? At this time, astronomy was constrained by naked-eye observations. Ancient Greek, Islamic, and European astronomers had cataloged stars, calculated planetary motions, and proposed models of the universe. Yet their tools limited them. Distant moons, faint stars, and the irregularities of planets were mostly invisible. The telescope, even in its crude Lippershey form, promised a leap forward. The curiosity-driven scholars of Europe immediately began experimenting. Telescopes were sent to Italy, Germany, and France, and soon a certain Italian mathematician and philosopher Galileo Galilei would take the device and wield it like a key unlocking cosmic secrets. A glimpse through Lippershey's eyes. Imagine looking through Lippershey's telescope for the first time. A distant church steeple appears enormous, a ship on the horizon seems close enough to toss a rope to, and the ripples of the canal glimmer in newfound detail. It's simple, yet magical, a small cylinder of glass that transforms reality. Though rudimentary, Lippershey's telescope embodies the essence of scientific progress, the combination of craftsmanship, curiosity, and experimentation. One man's tinkering in a Dutch workshop would set in motion a chain of discoveries that would forever change our understanding of the cosmos. It's worth adding a little humor here. Some accounts suggest that early users complained about nausea from the magnified images, or that telescopes made distant trees appear grotesquely huge. One can imagine a Dutch sailor shouting, "By the heavens, that cow on the hill is enormous," as neighbors stare in confusion. Even today, the mix of wonder and mild disorientation accompanies every great technological leap. Hans Lippershey's invention may have been humble, handheld, and initially intended for earthly observation, but its legacy is astronomical literally. It represents human ingenuity at its finest, the spark that would ignite a revolution in observational science. From spyglass to space telescope, it all begins here. A man, some lenses, and the audacity to look beyond what the eye can see. Galileo, the man who turned a spyglass into a cosmic key. In 1609, news of a new Dutch invention, a telescope, crossed the Alps and reached Italy. At the time, Galileo Galilei (1564–1642), a mathematician, philosopher, and professor at the University of Padua, was already known for his work in physics, mechanics, and mathematics. Yet, even for someone as brilliant as Galileo, the telescope was an opportunity waiting to be exploited. Picture him pacing his workshop in Venice, surrounded by lenses, and more lenses. Letters from Dutch spectacle makers had arrived, rumors were buzzing in scientific circles, and here was a device that could extend the human eye beyond imagination. For Galileo, this wasn't just a novelty, it was a tool for discovery, a weapon to probe the heavens, and potentially a challenge to centuries of philosophical dogma. Galileo didn't merely copy the Dutch design, he improved it. By experimenting with lens curvature and placement, he increased magnification from the modest 3 or 4 times of Lippershey's version to about 20 times, allowing unprecedented clarity of distant objects. His design retained the convex objective lens and concave eyepiece, now polished with meticulous care, but the real genius lay in its practical application. First glimpses of the heavens. The first public demonstration of Galileo's telescope was not to an academic audience but to Venetian officials. He presented his instrument as a marvel for military use, showing distant ships in the lagoon with astonishing clarity. He even demonstrated that from one vantage point, he could see the color of a ship's flag hundreds of meters away, a minor feat today, but in 1609 it bordered on wizardry. Yet Galileo's true curiosity lay beyond Earth. Turning his telescope to the night sky, he was greeted by an astonishing revelation. The moon, previously thought to be a smooth, perfect sphere, was cratered, mountainous, and uneven. Shadows danced across lunar craters, revealing a rugged topography. Galileo famously described it as a world much like our own, not the perfect and blemished orb imagined by the ancients. Suddenly, Aristotle's cosmology, the idea that the heavens were perfect and immutable, was in question. Jupiter and its moons. Next, Galileo pointed his telescope toward Jupiter. Through the eyepiece, for tiny points of light orbited the giant planet. Over several nights of careful observation, he noted their movements and realized these were moons revolving around Jupiter. He named them the Medicean stars in honor of his patrons, the powerful Medici family of Florence. This discovery was revolutionary. For centuries, astronomers had assumed all celestial bodies orbited Earth, as the Ptolemaic geocentric model dictated. Galileo's observations provided concrete evidence that not all heavenly bodies circled our planet, supporting the Copernican heliocentric model. One can imagine the reaction in Padua and Florence: awe, skepticism, and a healthy dose of panic among traditionalists. Scholars muttered, "The Earth is not the center. What next? Mermaids in the canals?" Galileo, ever confident, continued his observations with meticulous notes and sketches, forever changing humanity's cosmic perspective. Phases of Venus and Saturn's rings. Galileo's telescope revealed even more wonders. He observed the phases of Venus, demonstrating that Venus orbited the Sun, not Earth, a key argument for heliocentrism. He also glimpsed Saturn, though the telescope of the time was too rudimentary to reveal its rings clearly. Instead, he described the planet as having ears, perplexing astronomers for decades. Galileo's method combined careful observation with systematic recording. His sketches, sometimes accompanied by measurements, were remarkably precise. This blending of craftsmanship, science, and documentation set a new standard for astronomical study. One can picture him hunched over a table by candlelight, sketching the moon's craters, muttering to himself, "By Jupiter's moons, the universe is not as simple as the philosophers say." Publication of the Sidereus Nuncius Starry Messenger. In March 1610, Galileo published the Sidereus Nuncius Starry Messenger, a concise but groundbreaking report detailing his telescopic discoveries. The book included lunar maps, sketches of Jupiter's moons, and accounts of countless stars invisible to the naked eye. Its impact was immediate. Scholars across Europe marveled, debated, and sometimes ridiculed the findings. The Sidereus Nuncius was more than a report. It was a manifesto for the new science. Galileo demonstrated that observation could trump authority, that empirical evidence mattered more than tradition. In his words and images, one could see the universe opening like never before. Challenges and controversies. Galileo's telescopic revelations were not universally welcomed. The Catholic Church, wary of challenges to the geocentric model, was skeptical. Scholars and philosophers criticized him, some accusing him of optical illusions or misinterpretation. Yet Galileo persisted. He defended his work with clarity, reason, and, at times, a sharp tongue. Humor, often overlooked in historical accounts, was part of his approach. He reportedly quipped about those who refuse to see the moons of Jupiter because they are blinded by their stubbornness. The tension between observation and dogma would continue for decades, culminating in Galileo's trial in 1633. But the telescope had already irrevocably changed science. It was no longer a curiosity. It was an instrument of truth, capable of questioning long-held beliefs. Galileo's telescope, design and mechanics. Galileo's telescope was simple yet elegant. Its convex objective lens collected light from distant objects, while the concave eyepiece allowed the observer to see a magnified, upright image. The focal length of the lenses determined magnification, and the quality of the glass affected clarity. Unlike Lippershey's initial version, Galileo refined lens grinding techniques to reduce distortions, improving image sharpness. Despite its brilliance, the telescope had limitations. The field of view was narrow, chromatic aberration caused color fringing, and long viewing sessions could cause eye strain. Yet, for its time, it was revolutionary, a true extension of human vision, bringing the faraway near and the invisible visible. Legacy of Galileo's telescope. Galileo's contributions cannot be overstated. He transformed a simple Dutch spyglass into a scientific instrument capable of altering human understanding of the cosmos. His discoveries paved the way for Kepler's optical innovations, Newton's reflecting telescope eliminating chromatic aberration, modern astronomy, including satellites, observatories, and space telescopes. Moreover, Galileo's approach, observation, documentation, and critical analysis established the foundations of the scientific method, demonstrating the power of curiosity combined with technology. Galileo's telescope marked the transition from a practical device to a scientific instrument. While Lippershey's creations served eyes on the horizon, Galileo trained his on the heavens. Mountains on the moon, moons orbiting Jupiter, phases of Venus. Each discovery challenged the accepted view of the universe, highlighting the tension between human imagination and empirical reality. In short, Galileo didn't just look farther. He saw differently, opening humanity's eyes to a universe far more dynamic and complex than anyone had imagined. Through his hands, the telescope became a key to the cosmos, a tool not merely for seeing, but for understanding. Johannes Kepler, a visionary mathematician and astronomer. Johannes Kepler (1571–1630) was a German mathematician, astronomer, and astrologer, best known for his 3 laws of planetary motion, which describe the elliptical orbits of planets around the Sun. But Kepler was not just a theorist, he also contributed significantly to optics, including the design of an improved telescope. In 1611, he proposed what would later be called the Keplerian telescope, a design that differed fundamentally from the Galilean model. Where Galileo's telescope used a concave eyepiece to produce an upright image, Kepler suggested using a convex eyepiece. This seemingly small change had enormous consequences. It allowed a wider field of view, greater magnification, and sharper image quality. The trade-off was that images were inverted, appearing upside down or reversed left to right. For terrestrial observation, this could be disorienting, but for astronomy, it was a minor inconvenience compared to the benefits. Kepler also introduced improved calculations for lens placement and focal lengths, refining the optical principles behind telescopes. His theoretical work laid the foundation for later telescopes, including the refracting telescopes used in observatories and the design principles that Isaac Newton would later apply in creating his reflecting telescope. The Keplerian telescope, mechanics and advantages. The Keplerian telescope is, in essence, an evolution of the Galilean telescope. 1. Objective lens convex, collects and focuses light. 2. Eyepiece lens convex, magnifies the image produced by the objective lens. Because both lenses are convex, light rays converge in a focal plane before reaching the observer's eye. This arrangement provides greater magnification than the Galilean design. Better field of view, allowing observers to track moving celestial objects more easily. Enhanced clarity and image brightness, making faint stars and distant celestial phenomena observable. The primary drawback was the inverted image, which required either mental adjustment or additional optical components to correct. Nevertheless, the Keplerian telescope became the preferred design for astronomical research in the 17th and 18th centuries. The first 3 telescopes, those of Hans Lippershey, Galileo Galilei, and Johannes Kepler, represent a fascinating evolution of optical design and functionality. Lippershey's 1608 telescope, the very first practical model, used a convex objective lens paired with a concave eyepiece. Its magnification ranged between 3 to 9 times, making it a useful tool for navigation and military reconnaissance. While simple and handheld, it suffered from a narrow field of view and relatively low image quality, limiting its applications. Galileo's telescope, built in 1609 after hearing of the Dutch invention, retained the convex objective and concave eyepiece but improved magnification dramatically, reaching about 20 times. This refinement allowed Galileo to observe celestial bodies in unprecedented detail, including the moons of Jupiter and the rugged surface of the Moon, though the instrument still had a narrow field of view and suffered from chromatic aberration. Kepler's telescope, designed in 1611, introduced a convex eyepiece in place of the concave one, creating what became known as the Keplerian telescope. This design offered higher magnification, a wider field of view, and enhanced image clarity, making it superior for astronomical observation. Its primary drawback was that the image appeared inverted, which could be disorienting for terrestrial use but was negligible for studying the heavens. Collectively, these three telescopes illustrate a clear progression, from a practical spyglass for earthly purposes to a scientific instrument capable of revealing the cosmos in astonishing detail, each innovator building upon the achievements of the last. From this comparison, we see the evolution of telescopes from practical instruments to sophisticated astronomical tools. Lippershey's design served as the spark. Galileo harnessed it to unlock cosmic secrets. Kepler refined the physics, enabling centuries of discoveries to follow. Cultural and scientific impact: the invention of the telescope had profound implications. 1. Challenging the geocentric model. Galileo's observations directly contradicted the Earth-centered model, providing support for Copernicus' heliocentric theory. 2. Advancing the scientific method. Empirical observation, documentation, and repeatable experiments became the standard in astronomy and natural philosophy. 3. Expanding human perspective. The telescope transformed the night sky from a mystical realm into a field of measurable phenomena. It inspired curiosity, exploration, and a new appreciation for the scale of the universe. Cultural reactions varied. Some scholars and clergy rejected telescopic discoveries as heretical or optical illusions. Others embraced the innovation as a testament to human ingenuity. Across Europe, the telescope sparked intense debate, experimentation, and dissemination of knowledge, a Renaissance scientific revolution in miniature. Legacy and modern connections. The Keplerian design, combined with Galileo's discoveries, paved the way for later innovations. Isaac Newton, 1642 to 1727, developed the reflecting telescope, eliminating chromatic aberration inherent in lenses. Modern refracting telescopes, observatories through the 18th and 19th centuries used Keplerian principles to study stars, planets, and nebulae. Space telescopes: Hubble, Webb. Advanced optical design principles from Lippershey, Galileo, and Kepler still underpin today's most sophisticated instruments. In essence, the first three telescopes were stepping stones, each building upon the last to extend human vision from earthbound observation to the far reaches of the universe. Looking back, from humble spyglass to cosmic vision. Consider this: a man in Middelburg tinkering with lenses, a curious Italian mathematician peering at Jupiter's moons, and a German theorist redefining optics all contributed to humanity's ability to look beyond the limits of our eyes. Each invention, while imperfect in isolation, collectively formed the foundation of modern astronomy. Even today, amateur astronomers can trace their lineage back to these innovators. Backyard telescopes, once sold as simple toy spyglasses, carry centuries of accumulated knowledge. The essence of exploration, curiosity, and ingenuity remains unchanged. A touch of humor. It's worth noting the amusing side of these early telescopic adventures. Sailors squinting through a Lippershey spyglass may have panicked at giant cows on distant hills. Galileo's early sketches of lunar craters probably inspired imaginative readers to think the moon was inhabited by tiny lunar villagers, and Kepler's inverted images. Observers likely spent weeks adjusting their brains to interpret upside-down skies, a mental workout worthy of any modern astronaut training. History, after all, isn't just serious dates and names. It's a human story of trial, error, wonder, and occasional confusion. The first three telescopes, Lippershey's, Galileo's, and Kepler's, collectively transformed human understanding. From humble lenses to revolutionary observations, these instruments demonstrated the power of innovation and experimentation, advanced the scientific method, challenged philosophical and religious assumptions, paved the way for centuries of astronomical research. By looking farther, humans learned more not only about the cosmos but about the very process of discovery itself.
And there you have it, fellow stargazers. From Hans Lippershey's modest spyglass in a Dutch workshop to Galileo pointing his telescope at Jupiter's moons, and finally to Kepler reshaping optics with his brilliant design, we've traced the remarkable journey of the first three telescopes ever invented. If you've enjoyed this cosmic adventure, give yourself a high five. You've just traveled over 4 centuries of science, invention, and sheer human curiosity. Now, telescopes have evolved beyond anything our three pioneers could have imagined. We have space telescopes like Hubble and Webb peering into galaxies millions of light years away. But it all began with a few carefully polished lenses and the audacity to look further than anyone had before. If you like this deep dive into the origins of telescopes, drop a comment below. Which discovery would you have loved to witness through those early instruments? The craters on the moon? Jupiter's dancing moons? Or maybe just a really big upside-down cow in the Dutch countryside? And don't forget to hit that like button, because sharing curiosity is basically the telescopic equivalent of pointing at a star and saying, "Look at that." For more adventures in science, history, and the hidden stories of our universe, make sure to subscribe and ring the notification bell. We'll be exploring everything from black holes to quarks, from ancient astronomers to the next generation of space explorers. Remember, every great discovery starts with a single curious glance, and maybe a tiny cylinder of glass. Until next time, keep looking up. The universe is vast, mysterious, and waiting for the next person brave enough to see it clearly. Stay curious, stay inspired, and I'll see you in the next cosmic journey.